everybody, my name is Hassan. I'm a developer advocate at Vercel, and I'm very excited to talk to you today about building headless e-commerce apps with Next.js and Swell. Headless e-commerce, decoupling the head or front end of your website from your backend, has been an emerging trend in the e-commerce industry over the past few years, and it looks like it's here to stay. Let's explore what building a headless e-commerce site looks like by starting with a static Next.js app, adding data and APIs from Swell, which is a headless e-commerce backend, and going over different data fetching techniques in Next.js, including one of our most requested new features, on-demand incremental static regeneration. This is our demo, a coffee delivery app called the Coffee House. You can see we have a header with an image that says life is better with coffee, a button that says shop coffees that just scrolls down into this grid of products that we display, and then a footer component all the way at the bottom. So let's dig into the code. We're going to go into pages and index.js because that's the code for our homepage. And you can see here, first off, we have a getStaticProps function, which is a Next.js function that runs at build time. And this is returning some data. We have an array of 8 objects over here with some hard-coded data, including the ID, the image source, which is pointing to our public folder because all of our images are stored locally for right now. We have some price information, the name, and the calories. So if I minimize this data, you can see that we're importing it into our main home component as props. And then all the way at the bottom here, we have a CSS grid, and we're mapping through that data, and for each piece of data, we're displaying it on our page using this product card component. And then over here, we're importing a header. We have an H1 that just says crafted by us for you, and we have a footer at the bottom here. So let's actually explore the header, product card, and footer components because you can see we're importing them from the components folder. So we're going to go into components, we'll go into product card, and this is essentially just an image with some extra styles to provide like a cool blur in image effect that we can see if we go and we refresh the page. You can see how it comes in. That's all, this loading state and this function over here and some of the classes over here are doing. Besides that, we're just displaying some information about the product, like its name, its price, and the calories that we have. We have a header component that's also pretty straightforward, just a background image, some text, and a button that scrolls down into that H1. And then a footer that just says powered by Next.js, Swell, and Vercel, and has an image for our source code. Now that we've explored our starter code, let's move this static data into our Swell store and connect our Next.js app with our Swell store. So I'm going to go ahead and go to Swell. You can go to swell.is and create an account. And I did that, and I just added a few products right here. So all the products that we have over here, I added them. And if you click on anyone, you can see that, there's just a name, an image, a price, an option that I added like calories, and a description. So that's all I did. I went and I added those 8, and let's actually look into connecting Swell with Next.js right now. So the way we can do that is go to the Swell docs, and we can use the swell-js library. So we're going to hit npm, grab this, and we're going to run this to install this library, and then we're going to create a swell.js file, which I just did. And we're essentially just going to init Swell with certain environment variables. So over here, we're using these 2 environment variables, next public Swell store ID and next public Swell public key. And we can get both of these by going to Swell, going to developer API keys, and there's a store ID, and there's our public key. So we're gonna go ahead to our .env file and just grab those and put them in here. So now we have Swell with its environment variables, and we init it, we export it. So now we can import it in any of our pages and just use it. So we're gonna go to our index.js. We're going to import Swell from that specific file. So import Swell from Swell, and in our getStaticProps function, we're going to use the Swell API to grab a list of all of our products. So let's go to the Swell docs, we'll click products, and we'll see that this is what we need to use, await swell.products.list, right? So we're gonna create a variable called Swell products. We're going to use await swell.products.list to get a list of all the products. And now we can actually delete this big array of all of the static information, and we'll just put Swell products in there instead. We're also going to comment this out for the time being because we're going to have to change something based on the shape of the data. So now we're actually using the Swell API to fetch these Swell products. We're feeding it as props in this getStaticProps function, and we're getting it in our main page, and now we can do whatever we want with it, right? Let's actually just console.log it, data from Swell, to take a look at what we have. I'm going to kill our server and do it, spin it up again, and then we can go to our console, and we can see that there we go. We have our data from Swell. We have, it's all in results. You can see it's a list of 8 objects, and it has all of our data, nested in. We have our name, we have our price. The images are like inside of this images array. And then inside of that array, there's a file object, and then we have the URL, right? So we have to kind of pick the data that we want from here. So we're going to go down here. We're going to uncomment this out. And now it's going to be, instead of data, it's going to be data.results, because that's the array we want to go and search through. So data.results.map. And we're going to get errors because the product card component, we're going to have to go to the product card component and change a couple things. So let's just do that right now. We're going to go to product card, and we're going to want to change this image source and the calories. I think the rest are the same. The name and price are done in that specific way. So we're going to change that. Those 2 values we're going to save, and there we go. We are now using Swell to grab all of this information and then display it in our Next.js application. And we can prove it, right? We can go into our Swell app. We're going to go to products, and we're going to just edit one, right? For ice latte, we're going to say ice latte, question mark, exclamation point, and then save it and reload our page. And there we go. We have ice latte. So this is directly connected to our Swell store. And this is just barely scratching the surface of what we can do. We're also going to go over how to use Swell to add these specific products to our card and check out and do all of that stuff. Let's create the individual product pages using dynamic routes. The idea is that we want to click any of these product components and be directed to a new page with a checkout button that we can click and actually go through the full checkout flow using Swell's APIs. So let's get into it. The first thing we're going to want to do is go to our product card component and wrap everything in a link. So we'll import link from next link and wrap this whole thing in a link tag. We're also going to make this an anchor tag because that's recommended, and add an href here to go to /products/ and then we're going to use the product ID. Remember, we have our product as a prop here, so we can do that. Now all of these should have links, which is great, and we can click on them, and we get an error here because we don't have anything defined in that route. I just defined it over here, products, and then slug.js. We have it in square brackets because it's a dynamic route. We don't have anything here, so we have an error, but you can see that it actually, navigates to that specific URL, which is awesome. That's what we want. So now in our dynamic route, we can import certain things, and then we can use getStaticProps to actually grab this ID from the URL and then use Swell's API to grab information about that product and return it as a prop. We also need to use the getStaticPaths function because this is a dynamic route and it's required. And what we're doing here actually is we're also generating these paths in advance so they can be static. And then we're going to define our main component over here, which again is just the image, the name, the price, the description, and then a checkout button over here. And this uses a function called checkout that we're going to define here right now. So in this checkout function, what we're going to have is we're first clearing the Swell cart using this swell.card.setItems. We're adding the item to to the cart, and then we're finally navigating to the checkout URL that Swell gives us using the Next.js router. So let's save all of this, go back to localhost 3000 and make it full screen and watch this in action. We're going to go ahead and click iced coffee, for example. And we see that this is the page that we defined, just an image and a description and a button. We're going to click the checkout button, and we see that it navigates us to the Swell API checkout flow. So I'm going to enter some dummy data, and we'll see that it's going to work. And we see that our order has been completed. We can go to our Swell dashboard and go to orders and see that we have just done that, right? You can see that I paid for this iced coffee and we get all the information right here. Let's talk about data fetching techniques in Next.js and how to achieve great developer and user experience when dealing with static and dynamic content like we are in our e-commerce application. First, we could have done client-side rendering using something like useEffect or SWR. The issue with this is that it could introduce layout shift, which is bad for core web vitals. It likely needs additional loading and fetching logic, and it also runs on every request, which we want to avoid. Ideally, everything that can be static should be static. This brings us to our second method, static site generation. This is what we actually used in our demo application with getStaticProps, which only runs at build time. The issue is we couldn't actually see this when developing locally because Next.js runs getStaticProps on each request, only when we're developing locally. So we weren't able to see how fast it is and how it behaves in a production environment. To do this, let's build locally and then run it. We're going to build our site locally, and then after it's done, we're going to run npm run start to run the production server. We can navigate to localhost 3000 now. We can see that our website loads pretty fast, right? It's a static page. Even individual product pages are essentially instantaneous. The only issue with doing it this way is that we need to rebuild the entire site when we make a single change into our Swell product dashboard, for example. And this is a pretty big issue, especially for e-commerce applications like ours, because you can imagine, let's say we're having a sale and one of these coffees ran out and I want to update the status to be out of product. So I'd go to the Swell dashboard. Let's say our latte macchiato ran out. So we're going to make it inactive and save. But now if a customer is on the page, or even if a new customer comes in, he's going to see it as active and he's going to go and try to check out, and he's going to be frustrated when he either can't check out or it lets him check out and it just throws weird errors and he doesn't get his coffee, and you'll likely lose him as a customer. What if there was a way to have a static site but be able to update static pages after we've already built our site? This is where incremental static regeneration comes in, which allows us to use static generation on a per page level without needing to rebuild our site. Let's explore it by adding a revalidate prop to getStaticProps. We're going to go back to our code inside of our index.js file in getStaticProps and add a revalidate prop of 10 seconds. We're going to kill the server, build it again, and run our production build. And what this does is this will revalidate or regenerate the page every 10 seconds in the background. So if I run this, navigate to localhost 3000, and I go back to our products on Swell, let's make this active. I'll add some question marks and I'll make the list price $500. I'm going to save the product and I'm going to make this big and reload it. And you can see that we don't get the new product yet. And the reason is because we have to wait that 10 seconds and it's only going to revalidate a maximum of once every 10 seconds. So now if we refresh the page, we get it and we see it now. While this means our site can stay up to date, closer than completely rebuilding it every time there's a change, it's not a perfect solution because we have a lot of unnecessary regenerations. Let's say we want to update our site 5 times a day. If we have a revalidate period of 60 seconds, that means 3,600 regenerations per day. What if we could tell our Next.js site to regenerate certain pages only if there's a change made to our product page on Swell? Luckily, we came out with a new feature to ISR, which allows us to do just that, tell Next.js to regenerate certain pages on demand. Our ideal experience is changing a product on Swell or our Headless CMS or whatever backend we're using and being able to have it instantly change in our application. We don't want to worry about waiting for the revalidate period or rebuilding our site. We just want it to work right away. And this is exactly what on-demand ISR helps us solve. To use it, we're going to go back to our code and add an API route called revalidate. So I just added an API folder and a revalidate.js file. And we're going to go inside of here and we're going to define our API route. What this will do is when it's called, it's going to use unstable underscore revalidate, which is a Next.js function that allows us to revalidate specific routes. So this will revalidate our index route or homepage, and then this will revalidate the specific product page that got updated. This is really cool because we don't have to revalidate or regenerate the entire site. We can only generate the specific routes that we want. And then it just returns a true response. What we can actually also do is add some authentication over here to check if the secret from the webhook that we're going to define in Swell matches our revalidate environment variable that we can go ahead and define right here. So we're going to define a secret in our environment variable, and we'll just say testing for right now. Before we create our Swell webhook, we're going to want to deploy this to Vercel because it needs a public URL. So let's do that. After pushing your changes to a GitHub repo, we're going to go to the browser and go to vercel.com. We're going to create a new project, import that specific GitHub repo, and add our environment variables over here. After our environment variables are added, we can hit deploy and wait for Vercel to deploy our application. All right, our project is now deployed. Quick side note, if we go back to our index.js file, we don't need this revalidate prop anymore. So I'm going to save it and going to re-push my changes. Now that we have our application deployed, we can grab the link and head over to the Swell dashboard to add the webhook. So we can go to developer and then webhooks down here. We're going to add the webhook. We're going to paste this in. We're going to add revalidate. So it hits that API. And then we're also going to add that secret for authentication with the same value as the environment variable that we defined. We can call this on-demand ISR webhook, and we can select the exact events that we want this to trigger on. For us, we just want it to trigger on a product update. So right here, we'll go ahead and save this webhook, save the changes, and then go to our products page and see if we can trigger the webhook. So we're going to go to iced coffee, and we're going to change the name to iced coffee 33, and then make the list price $20. Okay, we're going to save the product, and then we're going to go back to our application. And I'll make this full screen so we can see everything, to iced coffee. So we're going to refresh the page and see that iced coffee gets updated, which is awesome. And then the specific product page is updated as well. We can also take a look at the headers to see that only these two pages were updated and no other pages were. So let's open up Espresso, for example, as well. So now we have the main page open, we have iced coffee open, and we have Espresso open. And I'm going to open up the developer tools for each one so we can take a look at the headers. Let's do that. So now that we have all the headers here, we can go ahead and update again from Swell and look at the changes. So now we're going to change it to iced coffee 55, and we'll make the list price $30. Okay, we'll save the product. We'll go back here, and we're expecting our homepage to be regenerated, right? So we're going to go ahead and reload the page. We can see that it was updated to 55. And we can go and see that, look at that, Next.js cache, it's revalidated, and it was a cache hit, right? We can go to our specific coffee page as well, reload, and see the same thing that, okay, it's revalidated. But then if we go to our other product page, normally nothing should happen to this product. It should just be a regular cache hit. We refresh and see that it is a regular cache hit. It wasn't regenerated. That's on-demand ISR in action. Thanks for sticking with me while we built that e-commerce application. The crazy part is we've only scratched the surface. It's a very simple e-commerce app overall, and you can also add subscriptions, discounts, checkout flows, and more with Swell at the click of a button. And then you'll likely want to add third-party scripts like Stamped for reviews, or Affirm for enabling customers to pay later, or Klaviyo for cart abandonment and emails. And you can do all of this in a performant way using something like Next.js in the script component. Thank you all so much for listening to my talk. Feel free to check out the GitHub repo with the link, and I'm at Netlope on Twitter if you want to say hi. My DMs are open. Thank you so much and have a great day.
Before we get started, I have two questions for you. Do you know what JSON Web Tokens are? Or do you know how JSON Web Tokens work? While I will give you a moment to consider those two questions, let me introduce myself. Hi, I'm just Temporal. My pronouns are she, her, and I'm a senior developer advocate at Octa 4.0. If you never heard of Octa or 0 before, no problem. We are an identity platform, which means we try to make it as easy as possible for anybody to implement authentication, so you can focus on building your products and all of those cool features. I'm also an instructor at LinkedIn Learning and Data Bootcamp, and I have a podcast about data science called Pizza de Dados. And it discusses data science in a fun way in Portuguese. So if you want to practice a little bit about data science and some Portuguese, you are more than invited to hear our episodes. I'm also the creator of Git Fishes, a collection of Git study cards to help you use Git. Finally, you can find me on the internet by the handle just Temporal. But enough about me. Let's go back to the issue at hand. What are JWTs and how do they work? And it is impossible to talk about JWTs, and yes, you can call it JWT or JWTs or JSON Web Tokens, without mentioning the effort that was made to create a collection of specifications and standards that are part of the JOSE specification. JOSE stands for JSON Object Signing and Encryption. One specification that is part of JOSE is the RFC 7519 that outlines what a JWT is. So imagine this. You need to create a format that can be used in a space-constrained environment to carry information from one point to another. Like, for example, an HTTP request. How would you do it? That's why JWTs are so widely adopted. The request for comment 7519 comes into play to outline what a JWT is and how it is structured. And this RFC is also commonly known as the JWT specification and is going to be our focus for today. So a JWT usually is a standardizing string that represents information in a compact way. Let's break down these three little letters. JSON means that we are going to structure the information that we want to carry as a valid JSON object. And you can use it in a JWT as long as it is any valid JSON object. The web part refers to the constrained environment that we have. Usually is the requests that web applications and APIs and online systems exchange in between front-end and back-end, for example. Finally, we have the token. And as a friend of mine likes to say, a token is a unique identifier representing something. So it conveys some meaning. And if you've never seen a JWT before, I'd like to introduce you your first JWT. Here's what it looks like. At a first glance, it seems like a random collection of characters. But if you look closely, you can see that the gigantic string have a structure consisting of three parts: a header, a payload, and a signature. The header contains information about the token itself. For example, what type of token it is, what algorithm was used for signing the token. So if you take this JSON object and encode it into a base64 string, we get the first part of our JWT. The payload, on the other hand, contains information about a resource. In a login scenario, for example, this would be information about an user. Like this slide here, I have an user information that would be, well, me. And it's also base64 encoded like the header. Now, before we talk about the signature, that is a little bit different from these two first parts, we must talk about claims. And each line, each key value pair of this JSON object represents a claim. And there are three types of claims. The first one, there are the reserved claims, and it comes from the JWT specification. There is subject, that usually is the ID of the user. There is issuer, who issued the token. And one important thing about this is that it's an expiry date. And one of the steps for validating JWTs is actually checking if the token is expired or not. The second type of claims that we have are the public claims. They aren't defined in the JWT specification, but they are standardized in a way by IANA, which is one of the organizations on the internet. And the idea behind it is that everybody would follow the same naming conventions for their claims. So, for example, we would use given name instead of first name and family name instead of last name, and so on. This way, everybody could know what each claims, what information means. And the last type of claims are the private ones. And they are supposed to be anything that you want. Anything that is useful and that you need for your systems to work properly. As long as you keep it a valid JSON, you can put anything that you want in there. Anything really. But keep in mind that the more information you have, the bigger the output string you're going to have to pass along on each request. So try to have a minimalist approach to the information in the payload and keep it only to the necessary information. Also, you may have noticed that the information in the payload and in the header are only encoded. So don't put sensitive data in the payload, because anyone could decode the base64 string and could get a hold of that payload, and we don't want that to happen, right? Now that you know what the header and the payload is about, it's time to take a look at the signature. And you may notice that the signature is a little bit different, especially because it is a way for us to verify that the token wasn't tampered with. That means that nobody tried to change anything in the token while it was in transit. Because the signature is based on the header and the payload, and depending on the algorithm, a secret or a key. Now, keep in mind that in real life, your secret would be something more like this. Usually, a secret is a random string that can be generated by using a secret generator, and it works like a password, and you should keep it safe. And there are two types of algorithms that can be used for signing tokens. The first type is the one that we just saw in the previous slide. So they are symmetrical algorithms. That's what they are called. It uses a secret to both sign and validate tokens. And the second type, the ones that I find the coolest, are the asymmetrical algorithms, like RS-256, for example. These type of algorithms, on the other hand, use a private key for signing and a public key for verifying the token. This way, you can keep your private key secure and share the public key so the other side can verify your tokens. And guess what? The Vercel specification actually defines a format for sharing public keys, known as JSON Web Key. JSON Web Keys, like JSON Web Tokens, have one RFC that outlines what they look like and what they should look like. And this RFC is the 7517. And if you are following the OpenID Connect, you will have a well-known endpoint that will make this public key available. In case you haven't seen one JSON Web Key before, Here's what it looks like. And it holds all the information about the public keys that you might need and all the mathematical properties required for using the key. And it's important to point out that you don't need to know which part of this JSON object means, because most languages actually have tools for using this structure without you having to manipulate it. So you don't need to worry that much about it. Now, let's create a token together. Why not? And the first thing we are going to do is take the header of my token that contains the information about the token itself and encode it into a base64 string that would look like this part. Then we can take the payload data and also encode it into a base64 string, and that would look like this. Notice the difference in size. Finally, we can create the signature by taking the payload and the header and passing along to algorithm and together with the secret, because this is the HMAC SHA-256 algorithm, and then we get the signature of the token or signing the token. If we bundle all of these pieces together by concatenating them with periods, we get our token. And if I copy this token, I can actually verify it. So if I go into JWT.io, you can check the contents of my token in the payload in the header and also verify the signature by pasting my token inside of this encoded area. You may notice that we have an example token. I'm just going to paste mine here instead of that one. And you can see here the information I had before. And you can also see that my signature was verified because this secret of the token is already here. So now that you've seen what all JSON Web Tokens are about, you may be wondering, where can you see it in action? And the good thing is, JSON Web Tokens can be used for many different things. And for example, if you're thinking of interacting with APIs, you may have heard of access token. And it's going to contain the data in the payload that is relevant for APIs like audience and scopes. Now, keep in mind that an access token doesn't have to be a JWT, but there is a brand new RFC that was authored by Vittorio Bertocci, Alzero's principal architect, and that came out in October 2021. And that outlines how to use JWTs as access tokens. And I recommend you read that for understanding what a JWT as an access token should look like and understand, for example, what claims and verification steps you are required for this type of tokens. Another way that you will see a JWT in the wild is being used as an ID token. And that's because ID tokens contain all relevant data about a user after the user is authenticated. So the front end can display the information about the user, for example, the username, the user profile picture, and so on, without making extra requests to the backend. And it is important to notice that as defined by the OpenID Connect, ID tokens are always JWTs. Now, since we are talking about tokens, you may have heard of refresh tokens, but it's important to know that usually refresh tokens are in JWTs. And that's why I'm not talking about it here in more detail at this time. Now that you've seen how JWTs are made, you may be wondering, what should you do to be safer when using JWTs on your application? And the first thing you should avoid is actually to store your JWTs in local storage. If you need it for validation purposes, you should store them in memory. This will help you avoid XSS attacks. Now, most of the times, we shouldn't verify JWTs in the front end. Your front end should delegate the verification process to the back end, but one thing you can do in the front end without verifying the token is actually checking the expiry date that comes in the payload. And you can already reject the token if it is expired. Finally, one last advice is remember not to put sensitive data in the payload of the token, because the payload is only base64 encoded and anyone can decode that token and grab that data. Speaking of tools, I showed you JWT.io before when we were validating our token, and other than validating tokens and checking the details inside the tokens, you can see a comprehensive list of libraries for dealing with JWTs in many languages that will help you properly handle JWTs. Also, at Auth0, we have a free book about JWTs with detailed information and more examples that we've seen today, and also best practices. I read it and I truly recommend it. Finally, to get all of these links, these slides were made available under the slides.com/jtemporal/JWT. And if you have any questions, you can find me on most social media under the handle Just Temporal. Thank you very much for your time, and I hope to see you soon. Bye.
Hey Reactathon, I'm Cecilia Martinez, Community Lead at Replay. I'm here today to talk to you about time, the next dimension in React debugging. Before we take a look at the future, let's see how things are now. Okay, so you have a bug. It's something that happens to every developer. Honestly, you probably have a backlog of bugs waiting for you right now to be reproduced, investigated, and resolved. In fact, developers spend up to 50% of their time debugging and maintaining applications. There are a lot of different ways to try and solve a bug. You can review logs, like error logs, also stack traces. You can kind of think of these as encoded messages coming from an informant that you have on the inside of your application. But they really only work if the informant is in the right place at the right time with good information. You can also inspect your application. You can inspect elements, network requests, even your component state and props. Again, this is very helpful for identifying the state of your application at a specific point in time. If you're manually reproducing your bug, capturing the right moment in time can feel like capturing lightning in a bottle. If you're using breakpoints, you may have more bottles, but you still have to make sure that you get it right about when the lightning will strike. One of my favorite books growing up was A Wrinkle in Time. There's one scene where the characters accidentally travel to a two-dimensional planet. So they feel this immense pressure when their three-dimensional bodies are shoved into a two-dimensional existence. They can't move, they can't breathe, and this is exactly what it's like trying to debug without the concept of time. Things happen in your application across periods of time. Your application renders, code executes, events are handled. These all happen across a period. However, traditional debugging tools only deal with specific points in time, usually after your application's already experienced an error. So think about a car mechanic. A mechanic will start your engine and watch it run. What if you could do the same with your application? Start it, watch it run, see what code executes, and see your application state at each point in time. Even better, what if you could rewind, fast forward, or even pause when an error occurs to investigate further? So that's what you get with time travel debugging. Replay lets you record your application execution once, replay it forever with all your favorite developer tools built in. This isn't just a recording, though. It's an actual replayable execution of your application's runtime. It's like going back into the past and reliving what's already occurred. Replay records runtime inputs and necessary non-determinism needed to replay the runtime after the fact. The runtime thinks it's interacting with a real user, with a real browser, talking to the real internet. It doesn't understand that it's actually in this simulated matrix world. Replay also doesn't just record the video for playback, it recreates the entire interactive session. This ability is what makes it easy to integrate with React dev tools. When replaying a website built with React, React interacts with React DevTools the same way that it does with a regular browser. When you want to view React DevTools at a certain point in time, Replay will actually send the code back to React DevTools and render it again as if it were happening in real time. So to view a component prop state and hooks, React DevTools sends an expression to the content script, which is then evaluated and returned. Replay fools React DevTools into thinking it's in a normal environment, when in reality, it's in this magical universe where time travel exists. So to borrow another example from A Wrinkle in Time, the ant on a string metaphor, with Replay, you can move through time two ways. You can move on a timeline, scrubbing forward and backward through your code execution and seeing each line hit as it executes. Or you can also bend time and go to a specific point of a execution of a function or a line of code in order to go exactly where you need in order to debug. So under the hood, Replay takes the program's entire execution and turns it into an object that can then be poked, prodded, evaluated, and analyzed. One of our engineers, Canon Vijayan, wrote about the unpredictable nature of applications and why you would need something like this. He says, "We don't understand all the possible ways in which the programs we have written can execute. When a program behaves in a way we don't expect, we are often at a loss and we want to know why." Turning the execution of your application into a debuggable object is possible with effective determinism. When Replay records, it partially records the low-level system interaction of the program from the start of the execution to the end. Then it reconstructs the execution on demand by re-executing it from the start in a virtualized environment using the previously recorded information to simulate the world as it was when that original execution occurred. This forces programs to re-execute the same way the second, third, even the 100th time. So you can read more about the details of partially recording and effective versus complete determinism at replay.io/effective determinism. But this is key to providing a fast, smooth time travel experience that should otherwise be impossible. So you can use the Replay browser to record your application manually. You can do this by recording a bug in a development environment, by QA teams recording in staging, or even by support teams and end users recording in production. But you can also record automated tests. This allows you to generate debuggable recordings of failed tests manually or more effectively in CI. With the Replay Playwright GitHub action, you can automatically create debuggable recordings of failed tests in CI. The GitHub action will comment on the pull request with links to these recordings so that you can have this reproduction of the failed test, debug it, and understand why that failure occurred. Also, with Replay Node, you can record node executions outside of the browser, also to create these debuggable assets. Later this year, we'll be exploring a always-on recorder mode. If you could just click save when an issue occurred, you would never have to worry about reproducing a bug. You could just save the replay and share it with your team. An always-on recorder mode also enables recording production node backends. This would allow crash reports that include a link to a debuggable replay so that you can travel back in time to when the error occurred without having to plan your trip in advance. So the best part is that this is just the beginning. We believe that the next step in framework debugging is enabled by time travel. When you're dealing with new dimensions of debugging, the conventional methods of showing information about the application don't always suffice. You're used to seeing data presented statically, representing a flat two-dimensional picture of your application. We're working on ways to help you better visualize your application state and execution across time with improvements to our React DevTools integration, as well as building out a Redux DevTools integration. So imagine being able to pause on a function definition and seeing the corresponding components highlighted in React DevTools, or stepping through the component stack of a rendering component the same way that you can step through a call stack. When inspecting an element, imagine seeing its React components, props, and state alongside its styles and attributes. Or seeing a Redux DevTools timeline of your recording so you can step into a dispatch and just start debugging from there. Imagine also inspecting a component and not only seeing its current props, but the previous props or next props. And then also imagine using the React DevTools profiler after the fact to analyze the performance of a replay session. So in order to make this happen, we're super excited to have Redux core maintainer Mark Erickson and React core maintainer Brian Vaughn now on the replay team to build out this exciting functionality. Doing the impossible does not come easily. It takes a great team and an even better community to help bring debugging into this new dimension. So if you'd like to help join us in pushing these boundaries, whether that be as a user, as a contributor, or as a member of the team, check out replay.io to learn more.